Hello everyone, welcome to your channel, that is Civil Engineering Choice. And today we are going to discuss this simply supported beam, shear force and bending moment diagram of this simply supported beam. And see, already I have uploaded one video how to calculate that shear force and bending moment diagram. Means how to calculate the shear forces, how to calculate the bending moment, everything that I have already uploaded. And today we are going to discuss how we can analyze that simply supported beam carrying 3-point loads in the STAAD Pro. Okay, so today the total training is based on the STAAD Pro. So we will start without wasting time. We will start the numerical. See, as I discussed, I have already uploaded video to calculation for the shear force and bending moment diagram. Okay, so here we are considering one simply supported beam, that is A and B, simple support at A and B. Then we are considering 3-point load, 5 kilonewton, 10 kilonewton and 8 kilonewton. Okay, so the distances are also given over there. One more important thing, I have already uploaded one video on the basics of STAAD Pro. Okay, so just go through that and refer all the videos, because I have explained each and every terms in detail in the previous. I will give the link of that video in the description box. Okay, but I request you, please refer that video also, so you will get better idea how I am modeling the total beam. Okay, so when we are starting to model any beam in the STAAD Pro, so we have to refer some steps. Okay, as a beginner point of view, you have to refer some steps. Like first step is prepare the geometry. Okay, first step, prepare geometry. So in geometry we have to add the nodes and the members that required as per the projects. Okay, what is meant by node members already I have discussed in previous video. Okay, then after that we have to define and assign the properties. Okay, property of the member, we have to define and assign the properties. Now in the third we have to define and assign the supports, okay, that are required for our structure. And the fourth one is loading. Okay, so whatever loading we are applying on our particular building or our model, that we have to define over here. And as we discussed, so many loads are there, like we know that dead load, live load, earthquake load, wind load. So these are the loads, and the STAAD is considering all these loads as a load case. Okay, all these loads as a load case. So whatever problem statement we are discussing over here, we are considering all load as a dead load. Okay, so one by one we will discuss how to add dead load, live load, wind load, earthquake load, everything that we will discuss in upcoming videos. Okay, now the fifth, once we complete all the steps like geometry, property, support, loading, and then we have to go for the analysis. Okay, then we have to go for the analysis and then check the results. Okay, so these are the general steps that we keep in mind when we are beginner in the STAAD Pro. Okay, let's just start with the model. So now, as we discussed in last video, when we are starting the modeling, so first we have to decide the nodes. Okay, and as per the STAAD Pro, every node have their coordinates. Okay, like x, y and z. Okay, so every node have the coordinates in x, y, z direction. So it means we have to decide the coordinates of all the structures. Okay, so if large building or large model is there, so in that case you can just start with the origin. You can just assign the origin and then we can model everything. Okay, that we will see one by one. But if some small member is there, like simply supported beam that we are discussing over here, so for that we have to decide first node. Okay, first node at the origin. Okay, and at the origin or at the starting of beam, the coordinates x, y and z coordinates are 0, 0, 0. Okay, so why we should start with the A, why not from B? Already we have discussed in previous videos, just go through that. Okay, then after you can consider nodes at the C point, then D point and E point. Okay, you can start like that also. Okay, but instead of that, what I am doing, I am directly considering second node at the B point. Okay, and in the second node, see our whatever model we are considering over here, beam, it is in plane. So as per the STAAD also, horizontal is x-axis, vertical is y-axis. Okay, when we are talking about the plane, so the x-axis is how much, y is definitely 0. Okay, y is 0 and z is 0, because the frame we are considering in the plane. Okay, so when we are talking about the x, so x is how much, means from A to B how much distance is there, so it is generally span. So how much span is there, 2 plus 2 4 plus 3 7 plus 1 8. Okay, so the total span is 8 meter. It means we can consider the second node having x coordinate is 8, y coordinate 0 and z coordinate is 0. Okay, so whatever C, D and E points are there, we will add that points in the STAAD Pro itself. Okay, that we will see how we can add, because it is the new part that we will learn today, how to add that point loads, how to add the nodes, everything. Okay, and if you see the shear force diagram, so at A point the reaction is 9.75, at B point 13.25. How to calculate, again I am repeating, I will give the link in the description box, how I have calculated the shear support reactions, shear forces, bending moment, and how I have draw this diagram. Okay, already we have discussed in the video, shear force and bending moment video. Okay, so the shear force at A point is 9.75, up to C is 9.75, and then 4.75. I will not going to discuss all the points because it will take time, because today we are focusing on the STAAD Pro training. Okay, STAAD Pro software. One more thing that we need to keep in mind when we are checking our results or the bending movement diagram in the STAAD Pro. So whatever diagram we are considering, or whatever diagram we are drawing in the theory, okay, so there we are showing the diagram or the bending moment, a positive bending moment is above the baseline. Okay, but STAAD Pro generally showing the elastic curve, and that elastic curve is below the baseline. So we will see such type of diagram in the STAAD Pro. Okay, so यही diagram हमारे baseline के bottom में होगी. So it is 19.5, so this value is 19.5, this is 29, so this value is 29, and this is 13.25, so this value is 13.25. okay, so the values will be same, only diagram is in downward direction because it's generally called as elastic diagram. Okay, it is called as elastic diagram, and how to draw that elastic diagram we will discuss it in upcoming videos. I will upload one video how to draw the elastic curve on the basis of bending moment diagram. Okay, so let's start with the STAAD Pro. So to start STAAD Pro, just type here STAAD Pro. So I have two STAAD Vieta and STAAD Connect, but we are using this STAAD Connect version. So just click on that STAAD Pro 2025. So once you click on that, you can see the software will open like this. Okay, and now here we are starting new beam. Okay, we are starting new project or new beam. So just click on the new. Here we can see the new option is there, so just click on that new. So once you click on the new, okay, so again one more thing that I have discussed in last video, when we are opening this software first time in your laptop or PC, so you have to configure it. How to configure it, already we have discussed it. Okay, now then just give the title of your project. Okay, so now here I am considering continuous beam. Just give the location. I want to save that project in the this folder. Okay, you can give another file name also. So just click on the browse and you can save it as per your requirement. Okay, now then select metric and analytical metric, and then click on the create. Okay, so just click on the create button. So once you click on that create, the model will start to create, or the STAAD will ready for the project. Okay, now the first time we can see such type of window. Okay, and in this window now we are starting to model that beam. So how we can model it beam? Okay, how we can model it? So just how we can model it? So just add first node, and the first node having coordinate 0 tab 0 tab 0, and the second node we are considering at the B point. If you see here, the second node we are considering at B point, and at B point the coordinates are 8 0 0. So just give here 8 0 0. Okay, now here you can see the first and second. Okay, both node we have added. Now suppose I want to see the front view, so you can go to the view and see here this option is available, front view. So just click on that. So see, the beams are horizontal, sorry, nodes are horizontal, it means we can see it is we can say it is front view. So now I want to add the beam, so right click anywhere in the window, then click on the add beam. See, the cursor has been changed. The cursor type already we have discussed in last video. So just click on the first node and then click on the second node. How to add beam, that also we have discussed in last video. This window and this window also we have discussed in last video. Okay, now I want to come out from that command, so just press escape button. Okay, now see, now we are in the beam cursor. So see, the first step that we covered, that is geometry, that is nodes and members we have added. Now here we are considering beam size is, let's say 230. Okay, 230 by 450 mm. Okay, we are considering beam size is 230 mm by 450 mm. So the second step, if you see here, we mentioned the second step is property. Property means what? We have to add the size of that member. Okay, and we are assuming the size is 230 mm by 450 mm. Okay, 230 by 450 mm means width is 230 and depth is 450. Okay, so to add that property, so just click on the property. See, next to the geometry one option is there, that is property. So just click on that property. Once you click on the property, here we can see on the right side the window has been changed now. Okay, and here just click on the prismatic. Okay, so once you click on the prismatic, all other options we will discuss one by one. So just click on the prismatic. So once we click on the prismatic, where we can see the prismatic and some options or some shapes are available over there. Okay, now here we are interested in the rectangular, because we assume our beam is a rectangle. So just click on the rectangle, and the first we have to give the yd is the depth. Here we can see the diagram is showing vertical distance is yd and horizontal distance is zd. So width is horizontal. Okay, always we are considering horizontal is width and vertical is depth. So the depth is, we assume 0.45. Why 0.45? Because we assume that dimension in mm, that is 230 mm by 450 mm, but now while giving that inputs in the STAAD Pro, we have to use it in meter or give it in the meter. Okay, the width is 0.23, and then select material as a concrete and then click on the add, close it. Now see, we have added that property, means define that property. We have not assigned that property to the structure. So just select this one, member, select property first, then select member, and then assign to selected beam. Okay, now see, the member, we have added beam property to the our member. Okay, one more thing that we need to consider over here. See, whatever load are there, that loads we are applying on the beams. Okay, so see, two options are there. You can add that load on the members, or we can add that load on the nodes by considering the nodes. So the first we will try to add that loads on the nodes. Okay, so to add that load on the nodes, we have to add the nodes. Okay, so to add that node, where we require, see, we require we have load at 2 meter from the A support, that is 5 kilonewton, then 10 kilonewton is there, that is 4 meter from the A support, and lastly 8 kilonewton load is there, and that 8 kilonewton load is having 2 plus 2 4 plus 3 7 meter distance from the A. So we have to add that nodes. Okay, so we require 3 nodes, and that 3 nodes having distance 2 meter, 4 meter and 7 meter respectively. So we have to add it. So how we can add? Just select that beam, then right click. Okay, so once we right click, here we can see insert node option. So just click on that insert node. Okay, once you click on the insert node, here we can see the beam is there, and that beam is having length 8 meter, that we assume, that that problem statement is saying to us. Okay, first node and second node. Okay, so now the first node, first point, or we can say the first node that we have to add at 2 meter. So just click distance 2 meter, then click on the add new point. Okay, the second node is at 4 meter, so 4 add, and the third one is 7, so 7 add. See, 3 4 5, these three nodes now we have added, and the distance is 3 node having distance 2 meter, 4 node having 4 meter, and the fifth node having distance 7 meter from the left support. And then click on the OK. So once you click on the OK, here we can see R1, 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 R1. 4 R1s are there. It means what? We have added the nodes, 3 nodes, and due to that 3 nodes, the beam has divided in 4 parts. Okay. So basically, the software will consider total beam as a one beam in the analysis. It will not consider the separate beam in the analysis, but geometry shows us the 4 different beams we have considered in the model. Okay, so just keep in mind, I'm repeating it. Model is saying 4 beams are there, but in the analysis the software will consider only one beam. Okay, now see, we are unable to see that node, okay, where we have added the node. To see that node, so just right click anywhere on the window, then click on the structural diagrams, and in structural diagrams, okay, in structural diagrams we can see in the labels, okay, see the node numbers, okay, node points. Now here we are interested to see the node points. Okay, so just click on the node points, then click on the apply, and then click on the OK. So once you click on the apply and OK, here we can see dotted dots, we can see dot points, we can see, it means we can see the nodes. Okay, again if you go with the that table, that is right click, then click on the structural diagrams, then click on the labels. So here we can see in the bracket some options, some words are given like node points K, node numbers N. Okay, so these are the shortcuts that we can use directly from the keyboard, but that word we have to use with the shift. Okay, suppose I want to see the node point, so press shift K, you can see the node points. Suppose node numbers, shift N, so we can see the node number. We will try it now. I want to see the node number, shift N, see 1, 3, 4, 5 and 2, these are the node, these are node numbers. Okay, again if I press shift key plus N, then the node numbers will hide. Okay, so to hide that node number and to see that node number, you can use shift N, node point shift K. Okay, node point shift K to hide and see. Okay, now we have added the node. The next step is what? We have added the properties. Here we can see, okay, geometry has completed, then properties also completed. The next one is the support, and we are considering simply supported beam. So what we can do to add that support, just click on the supports, and if you click on the supports, here we can see this window has been changed now. Okay, and we have to create first node. So just click on, we have to create support. Just click on the create, then it is simply supported, so just click on the pin. As I discussed in last video, it is not exactly pin, but how we can provide simply supported or simple support, that we will discuss later on. But now time being, consider pinned support. So just click on the add. Okay, see the support 2 has been added. So just click on that support, then select the node where we want to add that nodes. Okay, and see automatically my node, my cursor has changed. Okay, so here we can see this cursor. Okay, here we can see the arrow with some circle below that arrow, it means we are in the node cursor. Okay, now we have to assign the supports to that node. So just click on the supports first, then select these nodes, and then select assign to selected node and click on the assign. Okay, yes, see the node supports we have added to the nodes. The second step, third step, support we have completed. Now next one is the fourth, loading. So for loading, just click on the load. Okay, then click on the load cases, then click on the add. Okay, in the primary load we are considering only dead load now. Okay, give the name dead load. You can give that name as per your choice. Okay, I am considering dead load full name. Then add, close. Here we can see the first load case, dead load, that we have added, but under that dead load we are considering 3 loads. Okay, the loads are 5, 10 and 8, 5, 10 and 8. So just click on that dead load, then click on the add. Okay, So to add that load, we have added the nodes. That's why just click on the node points, okay, and whatever load we are applying, if you see the axis, global axis of that STAAD, so global axis, y axis is upward, so we have to apply or add that load in the y direction. So fy, in fy minus 5, y minus because of downward, okay, already we have explained in last video. The force load is 5 kilonewtons, so just click on the that fy, then type minus fy from the keyboard and then click on the add. So once you click on the add, here we can see the load we have added. The question mark is we have added that load, means we have defined that load but not assign it to the model, okay. The second one is minus 10, okay, add it. The third one is a minus 8, minus because of downward, okay, add. See, 4 load we have added. Now we have to assign that load to the nodes, okay. The 5 kilonewton load is at here, so just select that load, then select node, okay. Then how we can select node, okay. So to select that node, we have to select the node cursor first. So just click on the node cursor, then click on the load, then click on the load, and then assign to selected node, assign it, okay. See, then second node, second load, at the second node. So first select load, then select node, node, and then assign to selected node, assign it, okay. Now select third node, load, then select third node, and then assign to selected node, assign it. See, all load we have added. Now suppose I want to adjust that scale. How we can adjust? Just right click, okay, escape button, press escape button, okay, then right click, then structural diagrams, then scale, and in scale I want to change scale of that point load. So just increase it, let's say it's 3.5, apply and okay. See, okay. Now suppose I want to see the load values in the diagram, okay. Suppose I want to see that load values on the diagram. So right click, again go to the structural diagram, then go to the labels, and in labels here we can see the load values, okay. In bracket V is given, it means we can use the shift V shortcut for see that load. So just click on the load values, then apply and okay. See here, 5 kilonewton, 10 kilonewton and 8 kilonewton. We will cross check it. 5, 10, 8, okay. See here, 5, 10, 8, okay. So now here we have added the load, everything that we have completed. See, load, and now just go for the analysis, okay. So before analysis, as we discussed in last video, we have to give the perform analysis command first, and then we can go for the analysis. So for that, just go to the analyze and design, and in analyze and design go to the analysis command, and in analysis command just give the perform analysis command. Once you click on the perform analysis command, we can see changes over here. Click on the add. See, the perform analysis command has been added, then close it. Now we can add. So just click on the run, then click on the save. So restart it. It will take time, so that time is totally depend on the your project. If large project is there, so it will take time. Then go to the post processing mode and then click on the done, apply and okay. See, the first time when we analyze and when we are coming in the results window, result window means the post processing mode, okay. Result window means what? A post processing mode. So once we come in a post processing mode, then we can see the displacement window first. But now here we are interested to see the support reaction, shear forces and the bending moment, okay. So for that, what we can do, the first we will start with the support reaction. Just click on the support reaction. So once you click on the support reaction, here we can see the support reaction at A support is a 9.75 kilonewton and at B is 13.25. You can cross check it, okay. See here, if we see here, the at A point, okay, at A point it is 9.75 and at B point it is 13.25. So support reactions are exactly match. Now we will see that shear force diagram. So to see that shear force diagram, so just click on the beam results, okay, and in beam result just click on the FY, okay. So I don't want to see the MZ, so just click on the MZ. So see, this is shear force diagram, okay. Now if you compare with the shapes, the shape is matching, okay, shape is exactly matching, but we are interested in values also. So how we can see the values? So to see that value, just click on the layouts, okay, then go to the beam result zone and then click on the graphs. So once you click on the graphs, here we can see shear forces, okay. Now see, the first I have selected this beam. So in this beam I can see the shear force Fy is 9.75 and then 9.75. so at first node is 9.75 and here we can see the nodes, okay. If you see here, okay, so this indicate the node and this is also indicate the node. Let's say suppose I want to see the nodes in the diagram, so shift N, see this is first node and third node. So if I click over here, now I don't want to see that load, I want to see the shear force only. So just click on the shear force diagram, then click, I don't want to see that loads, so just click on the load, view load diagram, okay. Now here we can see only shear force diagram. See the shear forces. So at first node shear force is 9.75, means here the shear force is 9.75. At third node the shear force is 9.75, 9.75. Now I want to see the values for this beam, so just click here, okay. Again see here, at third node the value is 4.75, means shear force diagram is dropped over here, that is 4.75, and here also it is 4.75 for this beam, okay. For this beam just click over here. So fourth and fifth node, so fourth node diagram is 5.25, it is below diagram, okay, below the baseline, that is 5.25. Here also it is 5.25, okay. And then if you see here at the fifth node it is 13.3, minus 13.3, and the second node it is 13.3, okay. So here it is 13.3 and here also it is 13.3. and if you see this diagram with the, okay, with the और calculated value, यहाँ पे भी दिखाई देगा, see our calculated value, just wait, hope you can see it. See here 9.75, 9.75, at this location 9.75, 9.75, then 4.25, 4.25, okay. Then 5.25, 5.25, and then 13.25, 13.3 or 13.25, that is okay, okay. Now then let's check bending moment diagram, okay. So to check that bending moment diagram, again what we can do, just go to the STAAD Pro, then now I don't want to see the shear force diagram, so just click on that shear force diagram, okay. And now click on the MZ. So whatever bending moment, we can see that bending moment is about the Z axis, so just click on the MZ. See, this is the bending moment diagram. Now suppose I want to see the bending moments, so if I click over here, so we can see the bending moment at, now bending moment at first node, okay. Bending moment at first node is 0. Yes, obviously it is simply supported beam, so it should be 0. Bending moment at third node is 19.5, 19.5. Then if I click over here, bending moment at third node it is 19.5, that already we have written, and it at fourth node it is 29, okay. And then here fourth node fourth node it is 29, that already we have written, and here it is 13.3. okay, 13.3, and for this beam obviously it will be 0. okay, fifth node is fifth node is 13.3 and the second node is 0. Now let's check it with the bending moment diagram. See, 0, 19.5, 29 and 13.25 or 13.3. okay, so likewise we can check the shear force, bending moment diagram, everything, or we can analyze it in the STAAD Pro by using the basic tools. okay, so these are the basic tools, and definitely we are going in the higher side. okay, means we are going to analyze some portal frame, then some critical model, RCC building, steel building, everything that we are going to discuss one by one. okay, now here we are just learning the basic tools with the help of some basic numericals. okay, so I hope you are enjoying these videos, whatever videos I am uploading. So if really you are getting some knowledge from my video, so I will request you, so please subscribe my channel, like this video, subscribe my channel, and click on the bell icon so you can get that notification. okay, thank you so much.